Hello students, this is Dr. DA, and today you're going to be doing an activity called Experiment 7 in your lab manual. This is the reaction of a metal with acid. Our task is finding the equivalent mass of a metal. Previously on Chem 1A, we studied what is a neutralization reaction. If I react an acid HNX with NaOH, I get neutralization because the acid and base react to form a solution of salt in water. When we observe this equation, we can say that the acid HNX produces N moles of hydrogen ions. This is what happens to the acid. If N equals 1, we've learned that the acid is called monoprotic. If N equals 2, the acid is diprotic. And if N equals something else, it's so forth and so forth. However, we could also say that in this reaction, the acid HNX neutralizes N moles of NaOH. This perspective is not what happens to the acid, but what does the acid do to the base. This perspective reflects the chemical power of the acid. We would then say that 1 mole of the acid HNX has N equivalents. Now, what if we don't know the formula of the acid? So we don't know what the N is in HNX. Well, what we do is what we did before, which is you titrate a sample of mass, say M of the acid, against a standardized solution of NaOH. We use the data to determine the number of equivalents that were in that sample, and we calculate the equivalent mass of the acid, grams divided by numbers of equivalents. And then we can use other information to find the identity of the specific acid. If you forgot how to do this, please look up the experiment we did on the unknown acid, and we finding the equivalent mass of the unknown acid. Now let's consider a redox reaction, oxidation-reduction. Remember that in an acid-base reaction, you transfer protons. A redox reaction involves transfer of electrons. One of the reactions we saw is the reaction of a metal with acid. For example, the reaction of magnesium with HCl, which produces hydrogen gas. Remember that in a redox reaction, there are two components, two half reactions. In the oxidation half reaction, the magnesium metal loses 2 electrons to become the magnesium ion. And in the reduction half reaction, 2 protons coming from the acid are reduced with 2 electrons to produce hydrogen gas. We can say that 1 magnesium is capable of transferring 2 electrons. In other words, that 1 mole of magnesium has 2 equivalents of reducing power. So if we take 1 mole of magnesium and 2 equivalents in that mole of magnesium, and we multiply times the molar mass, 24.31 of magnesium per 1 mole, the moles of magnesium cancel out, and we have a result of 12.16 grams per equivalent. And we're going to call this the equivalent mass of magnesium. Remember, the difference between this equivalent mass or equivalent weight and that of an acid is that in the case of an acid, we were measuring the power to transfer protons. Here we're measuring the power to transfer electrons. Now again, what if we don't know the identity of the metal? Let's write out a unbalanced equation here where the metal reacts with HCl to produce a salt of the metal, which the formula will depend on what metal it is, and a number of moles of hydrogen gas. Well, remember, redox has 2 components. So the red part is the reduction, remember? This is where 2 protons receive 2 electrons to form hydrogen gas. In other words, it takes 2 moles of electrons, or 2 equivalents, to produce 1 mole of hydrogen gas. So here is our strategy. We react a sample of metal of a given mass M with excess hydrochloric acid. We then collect the hydrogen gas and we calculate how many moles of gas were produced. Let's call this N. And now we can calculate what is the equivalent mass of the metal. All right, so if we have M grams of metal that have produced, let's say, N moles of hydrogen, and it takes 2 equivalents for every mole of hydrogen produced, the moles of hydrogen cancel out, and so we have the grams per equivalent of the metal. Now we'll need, again, some additional information to use the grams per equivalent and then be able to identify who the metal was. So here is the procedure that you're going to be following today. First, you're going to measure a mass of the unknown metal. And at this moment, we have 4 possible candidates here. We have aluminum, zinc, lead, or tin. We're going to react the metal with excess HCl. We'll collect the hydrogen gas product. And then we'll measure the temperature, the pressure, and the volume of the collected gas. And then using the gas laws, we'll be able to calculate the number of moles of gas. And having the mass of the unknown metal and the moles of gas produced, we can calculate the equivalent mass of the unknown metal. Now, because we know who the 4 candidates are, and we know what are the ions, the cations that these metals produce, knowing the oxidation states of these possible cations of our metal candidates and the calculated equivalent mass, we'll be able to identify the metal. So please proceed to our next video where Dr. DA is going to demonstrate how the experiment is carried out. All right, and then we'll be back to do a mock set of calculations so you can see how the calculations for this experiment are done.